Good time, dear knowledge seekers. Now we are gonna talk about geophysics, but mainly about one of the famous survey, gravity survey. During presentation we will cover basic ideas and some advanced concepts of the method. Gravity survey measures the change of rock density by looking at changes in the gravity. This technology is used mostly in the minerals, coal and oil and gas industry. Gravity surveying provides geophysicists, geologists and exploration managers with a picture of the subsurface geology of a surveyed area, so they can see what is underground.
So if we talk about the Earth gravity field, the force of gravity is not the same all over the world. It varies at different points on the Earth, and the parameters such as mountains, ocean range and tidal movements, they are all affect the gravity measurements. The most important parameter is the rock density. Here on the picture you may see the range of most widespread densities all over the world. So even the small change in the rock density, it gives a high gravity anomaly. So the rock density depends mainly on the mineral composition, porosity, it is a compaction and cementation. The gravity measurements are based on the Newton's law of gravitation. So it is the same as the second Newton's law. So the acceleration is directly proportional to the mass of the Earth and inversely proportional to the radius of the Earth. We may take it as a basic and also use it to the another equations. So the units of gravity is very important. So there is a table that you have to always keep it in mind. So the gravity unit, the 10 gravity unit is equal to the 1 millijoule. So again, keep in mind that in environmental geophysics we are working with very small values, and we always have to remember it.
Measurement component. The causative body affects almost only on vertical component, since the angle do not play any role and resultant delta G is approximated to the delta GZ to the vertical component of the change. So lateral displacement among surface for short distances doesn't make any contrast in gravity changes. What about the shape of the Earth? Gravity varies with latitude because, firstly, non-spherical shape or oblate spheroid or polar flattened ellipsoid, and secondly, angular velocity on the Earth's surface decreases from a maximum value at the equator to a minimum value at the poles, and difference in equatorial and polar rising is equal to 21 km. At this slide we can see the formula which can help us to define the precise value of the gravity. It depends on the displacement upon the latitude and longitudinal direction. And for additional information, gravity at the poles exceeds gravity at the equator by 52,000 gravity units. Earth's shape. While we often think of the Earth as a sphere, our planet is actually very bumpy and irregular. The geoid is a shape that the surface of the oceans would take under the influence of the Earth's gravity and rotation alone in the absence of the influences such as winds and tides. This irregular shape is called geoid, a surface which defines zero elevation. So the rotation of the Earth causes the transformation from sphere to ellipse of rotation. Another factor affecting on the gravity is lithospheric movements or crust movements, which are creating peaks or mountains, or depressions, which are lower and higher than reference ellipse of rotation. In this case, it appears the problem when geoid and reference ellipse of rotation do not coincide with each other and bring incorrect data from excess mass, which we are counting as a causative body. In order to obtain the information, we have to make the measurement, and measurements are subdivided into absolute and relative. Absolute measurement is measuring things in a known amounts with a standard units. For example, we have a ruler and pencil. With ruler we measure the length of the pencil with one measurement. In a relative measurement is measuring something compared to another thing or estimating things proportionally to one another. For example, gravimeter. It uses some fluctuations of the mass body and converts it to the change in the gravity units.
So the conduction of gravity measurement depends on the Hooke's law. Here you may see the general formulas which are used in equipment and tools for calculating the gravity measurements. For gravity measurements we also use the springs and also the mass which is suspended to the spring, and we measure the time of the fluctuations in a gravity meter. The most widespread and most popular tool for the gravity measurement is Lacoste and Tromberg gravimeter. This gravimeter consists in a hinged beam carrying a mass supported by a spring which is attached immediately above the hinge. So the things that you have to know about this gravimeter is that the beam is made of bimetallic material and the spring is made of quartz material, and this is done for the constant temperature environment because the whole device requires a constant temperature. So the accuracy of this device is 0.01 milligauss. So the first method of the gravity correction is the free air correction. The free correction accounts for the extended radius to an observation point which is elevated to the certain distance h above sea level datum. So we have to bring this measurement point to the sea level datum, and we have to use the special formula which is shown on the picture. The free air correction is equal to the height times to the certain value. So what does this certain value mean? So as we go above from the sea level datum, we are changing the gravity attraction to the 0.308 milligauss per meter, and therefore we have to multiply it to the height. The next type of correction is the Bouguer correction. So we have to apply this correction when we also have some elevation distance from the elevation datum. And, we are assuming that the height is a layer of the rock with a certain density, and we have to either add or subtract it. If we know the density of that rock layer and the height, we may easily apply this correction. So the terrain correction is the correction for the Bouguer correction. Those corrections are always come with each other. For that method we have to use a gradical correction, and we conduct terrain correction in the mountain and valley regions where the surface and topography are very irregular. For example, we may see here on the picture, in the picture B, we have a certain mountain and certain trenches, and therefore we have to apply terrain corrections because those objects can generate a very high attraction of the gravity potential and the gravity force. The next type of correction is electrode correction. We have to apply it when we are measuring the gravity attraction of a surface on a moving vehicle. So there are only two factors that we have to know while we are conducting this correction. It is the speed of the moving vehicle and the geographical coordinates of the measuring point. Okay guys, thank you for your attention. This was a short overview of the gravity survey. I hope you like it and you will subscribe and join us.